Okay, so now why is this computer up here? Because warranty questions are something you're going to run into in real life. You buy a computer, they offer you a warranty. You buy an iPad, they offer you a warranty. You buy a iPod, they offer you a warranty. Seriously, you like buy a blender now and they offer you a warranty. You go into Home Depot and you buy a flashlight for $1 and they're like, you know, there's a warranty option on this thing. For only $1, you can buy this warranty. And seriously, it's just insane. Everybody's offering you a warranty. So I decided if it's a good deal. Well, Apple Care, I looked it up for this one. It's $169 for this $2,000 computer. And is it a good deal or not? Well, it really depends on one thing. What? If you knew your computer was going to break, wouldn't you buy the warranty? Yeah, in fact, actually, you probably wouldn't have bought the computer in the first place. But if you really wanted the computer, but you knew it was going to break in like 3 months, then you'd buy the warranty. So if you thought it isn't going to break, would you want to spend the $169 on that? No. So it really depends on whether it's going to break or not. So they'll never tell you that, and they don't know that for sure. They could tell you if they wanted to be nice what the percent chance is from their experience, but then you probably on average wouldn't buy the warranty. Because you know, you'd realize, oh, there's only a 3% chance that I'm going to use this warranty. Well, then I don't want it. But let's say there's a 10% chance. I'd like you to figure out, use the little start by all the possibilities, which are really simple on this. It either works or it breaks. And then the probabilities. And then times the amount you get if that happens. And then add them all up. Okay, give that a shot. Okay, who's got the two numbers? What's the top number? Negative what? 152, and the bottom number? Positive 183.1 or something, grand total? 31 is rounding, isn't it? But that's okay. Oh, it's 52.1, I got you, okay. So $31, it comes out positive, what does that mean? Now, an easy thing to get confused by is, wait a minute though, I paid $169 for the warranty and I'm only making $31. Well, we already factored in the cost of the warranty. So even if it came out to $0, then it was fair. So it came out above $0, so it's a good deal for you. Okay, so it was smart to buy the warranty in this case. It all depends though. You know, I heard at the beginning, they usually can fix this as the production goes on, but at the beginning, I talked to a guy who said that some of the screens on the Apples that were like peeling back, like the coating on them was peeling back, in which case it would have been a good thing to have the warranty, because even if it didn't peel right away, maybe it peels after a year and then starts looking nasty, and be happy you had the warranty. So then maybe more than 10% of them are going to get turned in for that. All right, moving on. This is a contingency table. That means that it's got a whole bunch of contingencies. As in, if this happens, well, it's this. Well, if that happens, it's that. Okay, well, this is 9th, 10th, 11th, and 12th graders, so it's a small school. And let's say that they were asked because some company like Bill Gates and Steve Jobs were like having a competition to try to see who was more popular. And they were going to say, well, if we're going to have, if you were going to be given a laptop, how many of you would rather have a PC? How many would rather have a Mac? I'm curious if I was going to give you, and let's say that they're both comparably powerful. Okay, so they're both comparable machines. How many of you would choose a PC? Raise your hand if you would choose a PC. Okay, 1, 2, 3, 4. Okay, how many of you choose a Mac? And that's everybody else. So it's like 25 to 3. And that's very interesting because, you know, for the future, right now, you're aware that it's like over 90% of all people who buy computers buy PCs. And that makes it interesting. Now, if the price was double, would that change your opinion? If you had to pay for it, in other words? Yeah. Does that change your opinion? Okay, so that's the thing you got to factor in too. All right, anyway, at this school, let's say that I pick a random kid. What's the probability I'll get an 11th grader who likes PCs? Tell me what to divide. What's on top? 90, because the 11th graders like PCs are right there. And what's on the bottom? There's usually a debate between 120 and 480. Which one do you think it is? 480, because I said it could be anybody. What if I said, I'm going to pick from the 12th graders, what's the probability I'm going to get a Mac liker? 20 over 120. And as soon as I said I'm going to pick from these guys, it's a given thing. That changes the denominator. Notice it goes from 480 to 120. Okay, so it's not out of everybody anymore. It's just out of 12th graders, which means it's out of a total of 120. So whenever you're given, change the denominator. All right, moving on. Let's say that we're talking about pizza questions. This is set up to have 16 toppings. This is actually off their website, and you get to choose 2 of them. If you do that, there are 120 different pizzas you could make. Okay, why did I use C and not P? Order doesn't matter. If you use P, then order matters. And nobody ever orders pizza and says sausage, pepperoni, and you better well put the sausage on first, or they're going to think you're a psycho. All right. How many pizzas could they make with 3 different toppings? Well, same thing. Just choose 3. All right. If you had to do this without a calculator, just a quick reminder. As in, I know calculators are going to be allowed in the final, and I know the final is multiple choice. But what if we put this problem and we said 6 factorial over 4 factorial, or here's another choice, 6 factorial over 4 factorial, 6 factorial, or 6 factorial over 4 factorial, 2 factorial, and I've done the classic, I put it in the C position, 6 factorial over, what would be another good option, maybe 2 factorial, 2 factorial, or something like that. Well, that's the one. That's for C. If that's the right answer for C, which is you take the top is always this number, the bottom is always this minus this, and one other thing, you also include one of those separately. Okay? If that's the right answer for the P's, sorry, the C's, and what's the right answer for the P's? Who wants to give it a shot? Mr. H. Mr. HM or HL. And how come your answer is going to be bigger than this answer? Because of that 2 factorial. And does it make sense that the P's should be bigger answer than the C's? Yeah, because the permutations, the order matters. So if I have a set of 2 things, or in this case, set of 2 things, then if I say Bob, Fred, if order matters, then I got to reverse it and say, or also Fred, Bob. And so it adds an extra twice as many things. Okay, so this would be twice as big as this would be. All right. I don't think I want to belabor that point too long. And we talked about that stuff already. So now it's combinations and tree diagrams. All right, if we were going to set up a tree diagram for this, it'd be a nightmare because you got to flip the coin 4 times. So the tree diagram would look something like this. Heads, tails. That's the first flip. And here's the second flip. And that seems like 2 more flips, but it's not. That's the first flip, and this whole column is the second flip because it's either this one or this one based on what happened the first time. And then the third flip is this or that or that and that. And then the fourth flip just gets insane. So tree diagrams can be a real pain. Do you remember the name? It starts with a B that can do the same stuff except it's binomial. All right. If you have something like this where you have a coin being flipped, a fair coin implies 50-50 chance, you'd go like this. C and then this. And I had 4 and I wanted exactly 3 tails. I'd put a 3 here. I have 4 flips and I'm choosing 3 to be tails, and I put tails in this spot and heads in this spot. The tails, if I want 3 of them, I put it here. 50-50 chance, and this would have to be what number right there? A 1, because these 2 have to together add up to 4. All right, let's see if you can set this up right now for a different situation. Let's say Ellie has got 3 chances to score, and let's say that when she kicks, she's got like a 30% chance that she's going to make it, but she's like on fire that game. And what's the probability that if she normally has a 30% chance of any shot going in, that she makes all 3 of her shots? Set up the binomial for me. See if we can figure it out. So in that scenario, there'd only be a 27% chance, a 2.7% chance that should make it. All three.